Cloud computing, also known as on-demand computing, is a kind of internet-based computing, where shared resources, data and information are provided to computers and other devices on demand. It is a model for enabling ubiquitous, on-demand access to a shared pool of configurable computing resources. Cloud computing and storage solutions provide users and enterprises with various capabilities to store and process their data in third-party data centers. It relies on sharing of resources to achieve coherence and economies of scale, similar to a utility over a network. At the foundation of cloud computing is the broader concept of converged infrastructure and shared services. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort. Cloud computing, or in simpler shorthand just the cloud, also focuses on maximizing the effectiveness of the shared resources. Cloud resources are usually not only shared by multiple users but are also dynamically reallocated per demand. This can work for allocating resources to users. For example, a cloud computer facility that serves European users during European business hours with a specific application may reallocate the same resources to serve North American users during North America's business hours with a different application. This approach helps maximize the use of computing power while reducing the overall cost of resources by using less power, air conditioning, rack space, etc. to maintain the system. With cloud computing, multiple users can access a single server to retrieve and update their data without purchasing licenses for different applications. The term moving to cloud also refers to an organization moving away from a traditional CapEx model to the OpEx model. Proponents claim that cloud computing allows companies to avoid upfront infrastructure costs and focus on projects that differentiate their businesses instead of on infrastructure. Proponents also claim that cloud computing allows enterprises to get their applications up and running faster, with improved manageability and less maintenance, and enables IT to more rapidly adjust resources to meet fluctuating and unpredictable business demand. Cloud providers typically use a pay-as-you-go model. This can lead to unexpectedly high charges if administrators do not adapt to the cloud pricing model. The present availability of high-capacity networks, low-cost computers and storage devices, as well as the widespread adoption of hardware virtualization, service-oriented architecture, and autonomic and utility computing have led to a growth in cloud computing. Companies can scale up as computing needs increase and then scale down again as demands decrease. Cloud computing has now become a highly demanded service or utility due to the advantages of high computing power, cheap cost of services, high performance, scalability, accessibility as well as availability. Cloud vendors are experiencing growth rates of 50% per annum, but due to being in a stage of infancy, it still has some pitfalls which need to be given proper attention to make cloud computing services more reliable and user-friendly. History of cloud computing. Origin of the term. The origin of the term cloud computing is unclear. The word cloud is commonly used in science to describe a large agglomeration of objects that visually appear from a distance as a cloud and describes any set of things whose details are not inspected further in a given context. Another explanation is that the old programs that drew network schematics surrounded the icons for servers with a circle, and a cluster of servers in a network diagram had several overlapping circles, which resembled a cloud. In analogy to above usage, the word cloud was used as a metaphor for the Internet, and a standardized cloud-like shape was used to denote a network on telephony schematics and later to depict the Internet in computer network diagrams. With this simplification, the implication is that the specifics of how the endpoints of a network are connected are not relevant for the purposes of understanding the diagram. The cloud symbol was used to represent networks of computing equipment in the original ARPANET by as early as 1977, and the CSNET by 1981, both predecessors to the Internet itself. The term cloud has been used to refer to platforms for distributed computing. In Wired's April 1994 feature, Bill and Andy's Excellent Adventure 2, on the Apple spin-off General Magic, Andy Hertzfeld comments on General Magic's distributed programming language Telescript that, "The beauty of Telescript is that now, instead of just having a device to program, we now have the entire cloud out there, where a single program can go and travel to many different sources of information and create sort of a virtual service. No one had conceived that before." The example Jim White, the designer of Telescript X400ASN1, uses now is a data arranging service where a software agent goes to the flower store and orders flowers and then goes to the ticket shop and gets the tickets for the show, and everything is communicated to both parties. References to cloud computing, in its modern sense, appeared as early as 1996. With the earliest known mention in a Compaq internal document. The popularization of the term can be traced to 2006 when Amazon.com introduced the Elastic Compute Cloud. The 1970s. During the mid-1970s, time-sharing was popularly known as RJE. This terminology was mostly associated with large vendors such as IBM and DEC. IBM developed the VM operating system to provide time-sharing services via virtual machines. The 1990s. In the 1990s, telecommunications companies, who previously offered primarily dedicated point-to-point data circuits, began offering virtual private network services with comparable quality of service but at a lower cost. By switching traffic as they saw fit to balance server use, they could use overall network bandwidth more effectively. Cloud computing extends this boundary to cover all servers as well as the network infrastructure. As computers became more prevalent, scientists and technologists explored ways to make large-scale computing power available to more users through time sharing. They experimented with algorithms to optimize the infrastructure, platform, and applications to prioritize CPU use and increase efficiency for end users. The new millennium, 2000s. Since 2000, cloud computing has come into existence. In early 2008, NASA's OpenNebula, enhanced in the Reservoir European Commission-funded project, became the first open-source software for deploying private and hybrid clouds, and for the Federation of Clouds. In the same year, efforts were focused on providing quality of service guarantees to cloud-based infrastructures. In the framework of the IRMOS European Commission-funded project, resulting in a real-time cloud environment. By mid-2008, Gartner saw an opportunity for cloud computing to shape the relationship among consumers of IT services, those who use IT services and those who sell them, and observed that organizations are switching from company-owned hardware and software assets to per-use service-based models, so that the projected shift to computing will result in dramatic growth in IT products in some areas and significant reductions in other areas. Microsoft Azure was announced as Azure in October 2008 and released on 1 February 2010 as Windows Azure, before being renamed to Microsoft Azure on 25 March 2014. In July 2010, Rackspace Hosting and NASA jointly launched an open-source cloud software initiative known as Openstack. The Openstack project intended to help organizations offer cloud computing services running on standard hardware. The early code came from NASA's Nebula platform as well as from Rackspace's Cloud Files platform. On March 1, 2011, IBM announced the IBM Smart Cloud Framework to support Smarter Planet. Among the various components of the Smarter Computing Foundation, cloud computing is a critical piece. On June 7, 2012, Oracle announced the Oracle Cloud. while aspects of the Oracle Cloud are still in development. This cloud offering is poised to be the first to provide users with access to an integrated set of IT solutions, including the applications, platform, and infrastructure layers. Similar concepts. Cloud computing is the result of the evolution and adoption of existing technologies and paradigms. The goal of cloud computing is to allow users to take benefit from all of these technologies, without the need for deep knowledge about or expertise with each one of them. The cloud aims to cut costs, and helps the users focus on their core business instead of being impeded by IT obstacles. The main enabling technology for cloud computing is virtualization. Virtualization software separates a physical computing device into one or more virtual devices, each of which can be easily used and managed to perform computing tasks. With operating system level virtualization essentially creating a scalable system of multiple independent computing devices. Idle computing resources can be allocated and used more efficiently. Virtualization provides the agility required to speed up IT operations, and reduces cost by increasing infrastructure utilization. Autonomic computing automates the process through which the user can provision resources on demand. By minimizing user involvement, automation speeds up the process, reduces labor costs and reduces the possibility of human errors. Users routinely face difficult business problems. Cloud computing adopts concepts from service-oriented architecture that can help the user break these problems into services that can be integrated to provide a solution. Cloud computing provides all of its resources as services, and makes use of the well-established standards and best practices gained in the domain of SOA to allow global and easy access to cloud services in a standardized way. Cloud computing also leverages concepts from utility computing to provide metrics for the services used. Such metrics are at the core of the public cloud pay-per-use models. In addition, measured services are an essential part of the feedback loop in autonomic computing, allowing services to scale on demand and to perform automatic failure recovery. Cloud computing is a kind of grid computing. It has evolved by addressing the QoS and reliability problems. Cloud computing provides the tools and technologies to build data, compute-intensive parallel applications with much more affordable prices compared to traditional parallel computing techniques. Cloud computing shares characteristics with client-server model. Client-server computing refers broadly to any distributed application that distinguishes between service providers and service requesters. Grid computing, a form of distributed and parallel computing, whereby super and virtual computer is composed of a cluster of networked, loosely coupled computers acting in concert to perform very large tasks. Mainframe computer, powerful computers used mainly by large organizations for critical applications, typically bulk data processing such as census, industry and consumer statistics, police and secret intelligence services, enterprise resource planning, and financial transaction processing. Utility computing, the packaging of computing resources, such as computation and storage, as a metered service similar to a traditional public utility, such as electricity. Peer-to-peer, a distributed architecture without the need for central coordination. Participants are both suppliers and consumers of resources. Characteristics. Cloud computing exhibits the following key characteristics. Agility improves with users' ability to reprovision technological infrastructure resources. WTF. Cost reductions claimed by cloud providers. A public cloud delivery model converts capital expenditure to operational expenditure. This purportedly lowers barriers to entry, as infrastructure is typically provided by a third party and does not need to be purchased for one-time or infrequent intensive computing tasks. Pricing on a utility computing basis is fine-grained, with usage-based options and fewer IT skills are required for implementation. The eFiscal project's state-of-the-art repository contains several articles looking into cost aspects in more detail, most of them concluding that cost savings depend on the type of activities supported and the type of infrastructure available in-house. Device and location independence enable users to access systems using a web browser regardless of their location or what device they use. As infrastructure is off-site and accessed via the Internet, users can connect from anywhere. Maintenance of cloud computing applications is easier, because they do not need to be installed on each user's computer and can be accessed from different places. Multi-tenancy enables sharing of resources and costs across a large pool of users, thus allowing for centralization of infrastructure in locations with lower costs. Peak load capacity increases utilization and efficiency improvements for systems that are often only 10 to 20% utilized. Performance is monitored, and consistent and loosely coupled architectures are constructed using web services as the system interface. Productivity may be increased when multiple users can work on the same data simultaneously, rather than waiting for it to be saved and emailed. Time might be saved as information does not need to be re-entered when fields are matched, nor do users need to install application software upgrades to their computer. Reliability improves with the use of multiple redundant sites, which makes well-designed cloud computing suitable for business continuity and disaster recovery. Scalability and elasticity via dynamic provisioning of resources on a fine-grained, self-service basis in near real time, without users having to engineer for peak loads. This gives the ability to scale up when the usage need increases or down if resources are not being used. Security can improve due to centralization of data, increased security-focused resources, etc. But concerns can persist about loss of control over certain sensitive data, and the lack of security for stored kernels. Security is often as good as or better than other traditional systems, in part because providers are able to devote resources to solving security issues that many customers cannot afford to tackle. However, the complexity of security is greatly increased when data is distributed over a wider area or over a greater number of devices, as well as in multi-tenant systems shared by unrelated users. In addition, user access to security audit logs may be difficult or impossible. Private cloud installations are in part motivated by users' desire to retain control over the infrastructure and avoid losing control of information. Security. The National Institute of Standards and Technology's definition of cloud computing identifies 5 essential characteristics. On-demand self-service. A consumer can unilaterally provision computing capabilities, such as server time and network storage, as needed automatically without requiring human interaction with each service provider. Broad network access. Capabilities are available over the network and accessed through standard mechanisms that promote use by heterogeneous thin or thick client platforms. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model, with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. Rapid elasticity. Capabilities can be elastically provisioned and released, in some cases automatically, to scale rapidly outward and inward commensurate with demand. To the consumer, the capabilities available for provisioning often appear unlimited and can be appropriated in any quantity at any time. Measured service. Cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service.